In this video, we are going to talk about integration by parts. So if you have an integral and there are two functions f of x and g of x being multiplied, and you have to integrate this integral with respect to x, then you can solve this integral question by integration by parts. What you have to do is you call one of the functions as the first function and the other function as the second function. It's not necessary that you call the first function as 1 and the next function as 2. So if you call f of x as the first function here and g of x as the second function, then integration by parts works like this. First function as it is, integral of second function with respect to x minus a big integral. Inside here, you find the derivative of the first function, integration of the second function, multiply this derivative and this integration answer together and integrate it once again with respect to x. You can see here that for the first function we have calculated the derivative, and for the second function we have 2 times calculated its integration. So we are going to call a function the first function for which we know the derivative, and we are going to call a function a second function only if we know its integration. Because in this formula of integration by parts, what we do is, for the first step, we keep the first function f of x as it is and we integrate the second function, which is g of x, minus we find the derivative of the first function and we multiply this derivative with the integration of the second function. Whatever are the answers for the derivative of first function and integration of the second function, we integrate it once again. So again, we are always going to call that function our first function for which we know its derivative, and we are going to call that function the second function for which we know its integration. There are some specific rules for calling a function a first function and calling other function the second function. When you are solving the question by integration by parts, you have to keep those rules in mind. Let's say we have to solve an integral x square e power x dx. Now we can see that two functions are being multiplied and we can find the integral by integration by parts. Now we will have to call one of these functions the first function and the other one as the second function. We know that we are going to call that function first function for which we know its derivative, and a function will be called a second function for which we know its integration. Now in this case, if we call x square as the first function and e power x as the second function, we will check if it is all right for us to call x square as the first function and e power x as the second function. For the first function, we have to know its derivative, and we know the derivative of x square, which is 2x. And we are going to call ex as the second function, but before that we have to check if we know its integration, and we know the integration of e power x. Yes, that is just e power x. So we know the integration of second function and we know the derivative of the first function. So yes, we can call them 1 and 2 respectively. But in this particular case, it is no problem if we call x square as the second function and e power x as the first function, because for the first function we should know its derivative. And do we know the derivative of e power x? Yes, derivative of e power x is e power x. And we are going to call x square as the second function, but before that we have to check if we know its integration. Yes, we know the integration of x square, which is x cubed by 3. So in this type of question, it is really no problem that what function we call the first function and what function we call the second function, because for both functions we know the derivatives and we know the integration. But in this case, what you have to keep in mind before you call it the first function or the second function, that always call that function a first function for which you know its derivative. In addition to that, if you keep on taking the derivative of that function, the derivative eventually vanishes. What are we saying is, if we call x square as the first function, we know that we are going to call a function a first function only if its derivative exists. Yes, the derivative of x square exists and we know it, which is 2x. But let's take another derivative here. It is 2. Let's take another derivative here, which is 0. So we are seeing that if we keep on taking the derivative of x square, it vanishes. So yes, this is a check that we should call x square definitely the first function. When we will be doing the questions, you will realize that this helps, that if a function has derivatives and those derivatives seem to be vanishing. In contrast to this, if we call e power x as the first function, we should know its derivative, and we know the derivative of e power x is e power x. But if we calculate its derivative again, e power x derivative is again e power x, we calculate its derivative again, which is again e power x. So no matter how many times we take the derivative of e power x, this derivative is never vanishing. So this is a check again, that if this happens, then we should not be taking that function as the first function despite the fact that we know its derivative. So again, if you have to make a choice that which function you should call the first function, so you should call a function the first function. For one thing, you should know its derivative. X square derivative is 2x, you know it. Okay, but you keep on taking its derivative, and if its derivative vanishes, then you will simply say that okay, fine, so let me call x square as the first function, then definitely you will have to call ex as the second function. That's the first thing that you have to keep in mind when you are going to call one of the functions first and another one the second. Now another thing is, if you have to solve this integral and now x square is being multiplied with ln x, so what function you should call the first function? We know that the derivative of x square is 2x, and then if you take its another derivative, it is 2. If you take its another derivative, it becomes 0. So by the previous suggestion, maybe you should take this x square as the first function. But remember that whenever natural log or ln x is the part of your integral, without thinking much, you call ln x as the first function. But whatever function we call the first function, its derivative is something that you should know. Do you know the derivative of ln x? Yes, we know the derivative of ln x, which is 1 over x. So again, whenever ln x is the part of the integral, without looking at the second function, you're always going to call ln x as the first function. Then you will have no choice but to call x square as the second function. Another thing that you have to keep in your mind is that, let's say you have to solve this integral x into tan inverse x dx. In this case, although you know the derivative of x and then its derivative is vanishing if you keep on taking higher order derivatives, but always remember that whenever there is a inverse trigonometric function involved, you are always going to call it the first function. Just like the previous suggestion, that whenever your function involves ln x, you are always going to call it the first function. The same way, if your integral involves trigonometric inverse function like sine inverse x, cos inverse x, secant inverse x, tan inverse x, cosecant inverse x, cot inverse x, you're always going to call it as the first function, and the other function will definitely be the second function. So this is how we decide what function is going to be the first function and what function is going to be the second function. Let's solve a question by integration by parts. We have to solve an integral x multiplied by e power x dx. Since two functions are being multiplied and we have to find their integral, so we will solve it by integration by parts. we will have to call one of the functions as first function and another one as the second. Now we know the derivative of x and we know the integration of e power x. Also, by using the first suggestion that you call a function the first function if you know its derivative, and if you keep on taking the derivative seems to be vanishing. So if we take x as the first function, we know its first derivative, which is 1. If we further take the derivative of 1, it is 0. So derivative seems to be vanishing. So yes, we are going to call x as the first function and e power x as the second function. Now by using the formula for integration by parts, which is this, we are going to solve this integral. Integral x e power x dx is equal to first function as it is, integral of second function is e power x, so we will integrate e power x with respect to x, minus big integral with respect to x. What do we have inside? Derivative of the first function with respect to x, integral of the second function with respect to x. Now we know that integration of e power x is e power x minus derivative of x with respect to x is 1. Integration of e power x dx is e power x. Then we will have to integrate the derivative and the integration answer again. So we have x e power x minus e power x dx. We know that integration of e power x is e power x, and we will add some constant. This is how we solve the integral x e power x dx using the formula integration by parts. Let's attempt another question. We have to integrate x into cos x dx. Since two functions are being multiplied, so we can apply integration by parts formula. But before that, we will have to call one of the functions as first function and another function as the second function. For first function, we should know its derivative, and for the second function, we should know its integration. We are calling x as the first function because we know its derivative, which is 1. Also, its continuous derivative seems to be vanishing. And we are going to call cos x as the second function because we know the integration of cos x, which is sin x. Let's apply the formula of integration by parts. First function as it is, integration of second minus derivative of the first function, integration of second, and this whole answer will be integrated once again. Integration of cos x with respect to x is sin x minus derivative of x with respect to x is 1. Integration of cos x with respect to x is sin x, and we will have to integrate this answer once again. X sin x minus sin x dx. We know the integration of sin x with respect to x is minus cos x. It's a formula, and then just add a constant. It is written as x sin x plus cos x plus some constant. So we have solved this integral x into cos x with respect to x by integration by parts. Let's solve another question. This time we have to find the answer of this integral. Now we know that if we have the integral 1 over 1 plus x squared dx, the formula says its answer is tan inverse x. But we don't know what is the integral of tan inverse x. So we can try to find the answer of integral of tan inverse x with respect to x by using the formula of integration by parts. But for integration by parts, we have to have the product of two functions inside the integral. But here we just have one function, which is tan inverse x. So what we can do is we can introduce and write 1 here multiplied by tan inverse x. It has not changed technically your question. Tan inverse x multiplied by 1 is still tan inverse x. But now recalling our third suggestion of which function should be called first and which function should be called second, we can see here that tan inverse x should be called the first function. Remember, we said that trigonometric inverse functions would always be called the first function and the other function would be the second function. The same way ln x would always be called the first function and the other function would be the second function. If we are calling tan inverse x as the first function, then we can call 1 as the second function. Now let's apply integration by parts formula. First function as it is, integral of second function is 1, so it's integral, minus derivative of first function, which is tan inverse x, integral of second function, multiply these two answers and integrate once again. It gives us tan inverse x, and we know that dx integral is x, so we have here multiplied by x, minus derivative of tan inverse x is 1 over 1 plus x square. Integration of 1 with respect to x gives you x and dx. X into tan inverse x minus x over 1 plus x square dx. Now let's solve this integral separately. X over 1 plus x square dx. Let's solve this integral by integration by substitution. How does substitution work? So you think of a function or a term such that its derivative is also written here. We can see that if we suppose 1 plus x square equal to another variable, but before that the derivative of this term should be here. What's the derivative of this term? Derivative of 1 is 0 plus derivative of x square is 2x. 2 is a constant but x is here. So yes, we can go ahead with this substitution and can call 1 plus x square as t. Differential of 1 is 0 plus differential of x square, first the power rule, 2x, and then the differential of x is dx and the differential of t is dt. From here we find the value of dx, which is dt by 2x, which gives us x over 1 plus x square is d, dx is dt by 2x. X cancels out with this x. I'm taking this 1 over 2 outside and you have this integral dt by t. You know that the integral 1 over x dx gives you ln x. So here we have 1 over t dt, which gives us ln t. But t was not originally the part of our question. We had assumed t to be equal to 1 plus x square. So the value of t here is 1 plus x square. See that the integral x over 1 plus x square dx is equal to 1 over 2 ln 1 plus x square. We will put this value of integral back here, which gives us x tan inverse x 1 over 2 ln 1 plus x square. We have solved this integral tan inverse x by integration by parts. So this question is completed. Let's attempt another question. We have to solve this integral ln x. We know that 1 over x dx is equal to ln x, but we don't know what is the integral of ln x. For this we are going to use integration by parts. But for integration by parts we need two functions, but here we just have ln x. So what we are going to do, just like in the previous question, we are going to put 1 multiplied by ln x dx. Now remember, Our suggestion when we have to decide what function should be called first function and what function should be called the second function, we decided that whenever there is ln x involved, it's always going to be called the first function and the other one will definitely be the second function. So here we are calling ln x as the first function and 1 as the second function. Now let's apply integration by parts. What does the integration by parts do? The first function as it is, integration of second minus derivative of the first function, integration of second, multiply these two answers and integrate once again. One integration, this is like just dx, which gives you x, minus derivative of ln x is 1 over x. This is dx integral, which is just x, integrated once again. This integral sign gives you x ln x minus this x cancels with this x, 1 dx. So you have x ln x minus dx, which gives you x ln x minus x plus some constant. You have just solved the integral ln x by integration by parts. Let's solve one more question for integration by parts. Let's say you have the integral x square into e power x dx. Now, what function should we call the first function? What function should we call the second function? We know the derivative of x square is 2x, and also if we further take the derivative of 2x, it gives you 2. The next derivative is 0. So yes, we are going to call x square as the first function and e power x as the second function, because we know its integral. Integral of e power x is just e power x. And now let's apply integration by parts. First function as it is, integral of second minus derivative of first function, integral of second function, and integrate it once again. X square as it is, integral of e power x is just e power x minus derivative of x square is 2x into e power x integral is e power x and integrate it once again. X square e power x minus, we take 2 out because it's a constant, x into e power x dx. Now please see this. X square ex will come as it is. But to solve this integral, this one, we can see that now again we have x being multiplied with e power x. So we will apply integration by parts again, but you have to pay attention here that whatever the function we called the second function, if it is appearing again in this integral, we are going to call it again the second function. For example, we called e power x as the second function. E power x is appearing here again, so we are going to call again e power x as the second function. At this step we cannot call it the first function because previously here we called e power x as the second function, and then if we have already called e power x as the second function, we are going to call x as the first function. And now let's apply integration by parts again. First function as it is, integral of second minus derivative of first function, integral of second, and integrate it once again. X square ex as it is minus 2x, integral of e power x is e power x minus derivative of x is 1 into integral of e power x is e power x and integrate it once again. We have x square e power x minus 2x e power x minus minus plus 2 e power x dx integral. We have x square ex minus 2x ex plus 2 integral of ex is just ex and we will put a constant. So we have just solved an integral x square e power x dx by integration by parts. Just remember, if you have applied integration by parts formula, and if you need to apply integration by parts again in the same question, you can do that. There is no limit to how many times you can apply integration by parts to bring a question to its complete end. This is how we apply integration by parts, and in the next video we are going to find the solution of the integrals by using the trigonometric substitution.